thank you for joining us today, and we're going to dive into why your security pipeline is broken and how to fix it. So really, this topic is about managing high-scale infrastructure for high-fidelity detection, part of your security monitoring strategy. So before we get started, a couple of housekeeping items. So we are recording this. We're going to follow up with the recording later today, so you'll have that in your inbox if you want to revisit some components of the content or share it with your colleagues. We're also going to be running some polls throughout, so use the polling functionality in the Zoom webinar to respond to those, and we'll get some engagement with the audience. And also on the point of engagement, we're going to be scanning for questions throughout, and then we've got 5 to 10 minutes at the end to answer those questions with a live Q&A. So please use the question functionality. We'll just address those at the end of the presentation. So let's go ahead and get started with introductions. So Panos, do you want to give a quick intro of yourself?
Yes, thank you, Brian. Hello, everyone, and thanks for attending. I'm Panos. I'm based in Athens, Greece. I'm a senior engineering manager in Panther. I've been with Panther a bit more than 1.5 years. I'm responsible, of course, for ingestion and threat research as well. And my background is cybersecurity and distributed systems.
Great. Super happy to have you, Panos. And I'm Brian Pease. So I'm a principal product marketing manager with Panther. I've been here for about 8 months, just leading all of our go-to-market messaging and some of our strategies around product launches. And also have a pretty good depth of experience in cybersecurity, early stage companies. So I'm really excited to talk to you all today. We're going to give a quick overview of the agenda. So first, context, how did we get here? Then we'll dive into some of the key components of your strategy when it comes to pipelines. And then we'll look at specific tactical processes and features that you might need to use for your security data pipelines. Then I'm going to hand it over to Panos. He's going to get in the weeds with some granular sample scenarios and demo how Panther can enable some of these pipeline capabilities. And then we'll wrap up with a recap of reasons why your pipeline might be breaking down and how to fix that. And then, of course, the Q&A that I mentioned before. So how did we get here? What's the background? So if you think about the SIEM market and the vendors in the SIEM space, this goes back to about 2 decades ago. And back then, it was all in a centralized system, a single pane of glass. And this made sense back then because this was basically pre-cloud. A lot of your infrastructure was on-premise. Your tech stack was more limited. Your IT footprint wasn't nearly as sprawled out. And that meant that you could ingest everything because your data sets were smaller. And that meant that there were more straightforward pipeline requirements. And also the monolith really reflects that everything was in the same system. So the legacy SIEM players would have your, all of this kind of in a walled garden. And that worked for a time, but today, with the explosion in data volumes, there are serious challenges related to scale, related to maintaining performance when you start to scale your systems. If you are able to maintain your performance, you're going to run into some pretty high costs. And also, as you get embedded into these more monolithic systems, it becomes really hard to migrate out of it. And vendor lock-in is kind of the result. So it's kind of like a ransomware business model. So that is fading slowly with a more next-gen approach. So instead of it all being kind of in a monolithic system, you can think about flexible, configurable building blocks. And this aligns to the more everything is code philosophy for monitoring all of your security data. So decoupling the acquisition of the data from processing and analysis of it from the storage of it. And then you can even decouple things like storage further to where you have some components that are like a high-scale, high-performance data lake, some components that are just in low-cost S3 buckets or blob storage, right? And with the modular approach, you can mix and match like building your own open source components with implementing best of breed vendor software. So one thing that's really important with this system though is the ingestion pipeline is the first link in the chain. So you want to make sure that foundational building block is high performance and can enable the high scale that you need, right? So With a high scale, high performance pipeline, you're going to have positive benefits throughout your entire SecOps program. Your data sets are more focused, higher quality. That leads to faster processing of your detection rules, of your search queries, higher fidelity detections. You can more rapidly investigate issues because the results on your searches run faster, and things are a lot more cost effective at scale, right? So obviously there's a lot of ways and paths to get onto this SIEM journey. So I wanted to run up a quick poll to kind of see where everybody's at on their journey. So use the Zoom webinar capabilities to respond to the poll. So Olya, can you launch that there on your side? All right, so we're getting some good responses here. Okay, cool. So it looks like, I'm gonna end the poll now. So it looks like we've got a lot of folks on the call that are really kind of like already in the next gen SIEM, and they're focused on optimizing the pipeline, which is good, right? Like, you know, a lot of inefficiencies with some of that more monolithic approach. So, all right, so here's the results. Okay. All right, so now let's dive into some of the strategic considerations, right? So one thing you want to keep in mind is cost. Obviously, your budget is going to dictate what you can do. Then you need to look at your log priorities and kind of figure out what's the highest value things you need to monitor. And then with those two things, you can start thinking about when is this data going to be the most valuable for analysis, and how can I optimize performance and cost based on time frame. So really quickly on the cost side, whatever technology that you implement is going to have some direct costs. So you're going to have licensing fees, you're going to have some infrastructure for computing, you're going to need to pay for some storage, there's going to be some base and retention, there could be some add-ons, and also whether or not you're hosting on premises or the vendor is hosting in a SaaS deployment is going to affect how these costs are reflected and how they're quoting you. So it might not just be broken out into these categories, but these are the components of the cost. And then you've got indirect costs that you might need to consider, like investing in talent, managing processes and change management, and negotiating with vendors. But really, the key strategic exercise for your pipeline is really knowing what priority logs need to be in the system. And in order to make those prioritization decisions, you need really, really in-depth knowledge of your IT infrastructure and the footprint, and then what threats that you're the most susceptible to. So it's going to vary by your specific circumstances, but at a general level, some things that are high priority might be different cloud services, whether it's like AWS Cloud Trails and like network operations in the cloud, could be more like containers and Kubernetes clusters, other infrastructure for like serving and processing workloads. So that's one category. Your endpoint or network security solutions. So think about things like EDR and XDR. Think about like intrusion prevention systems and next-gen firewalls. Those are really important. And then all of your identity providers and authentication and single sign-on. Those are going to be really important, especially correlating actions across different logs. And then data stores, specifically data that is regulated, or maybe it's intellectual property, or it has internal financial information, that's higher sensitivity. So you might need to think about making sure that that is being monitored more closely. So kind of a second order thing on top of priority is knowing the shape of those logs. So whatever format you have your logs in, that's going to dictate some of the requirements that you have for your pipeline capabilities. So if you have custom logs in non-standard formats, they might need a little bit more heavy lifting in terms of parsing, transforming, and then normalizing that data to make it ready for analysis. Generally, lightweight formats like JSON are a little bit easier to analyze, but there are plenty of caveats there. So I think Panos.
Something maybe we can add here is that logs in JSON format are preferable, but of course they're not a silver bullet. For example, it's very common to have properties with very high value for context, for detection context and investigation context, buried very deeply in nested properties, right? Which makes it more hard to access and reference. So there are cases that, heavy refinement is needed even in JSON formats.
Right on. Yes, that's a good point. There's no silver bullet here. So, but you know your formats of your logs. Next thing you're going to need to look at is the volumes of your logs and how they are relative to each other, right? So there's inherent relationships between the priority logs that you have, what volumes of data those logs have, and then how that's going to impact costs for your pipeline and for your security detection and monitoring program in general. So we'll get into the details of this in the next section in a few minutes, but if you have higher volume logs that are incredibly high value and priority, those are where you want to think about ways that you might want to filter out components of the data to make the data set more manageable and reduce cost. So, but we're going to launch another poll here. Want to learn what are some of the categories that are the highest volume logs in your environment. So just launched that. Give you all a chance to take a look. So give a few more seconds for everybody to respond here. Come on, let's get those in. Okay, got 4. All right. All right, let's go ahead and end the poll. So it looks like most of the highest volume logs are actually in the endpoint detection. So these are things like I mentioned, EDR, XDR, like CrowdStrike, SentinelOnes, and those do generate a lot of telemetry data, so that does make sense. So, all right, let's jump back into the presentation. So the other thing you want to think about for your strategy is the time frames when the priority logs are going to be most valuable for immediate analysis versus some data points are going to be not quite high value in themselves, but they can be correlated with other data points. That's kind of your near-term bucket. And then you're going to have probably a higher proportion or higher volume of data that's not going to have immediate value to your security monitoring, but you might need it for compliance reporting. You might need it for things like training your threat models. So that's where you can think about operationalizing this to balance the speed, performance, and cost, where you're bringing in your high value data sources and running real-time detections for immediate analysis. So if there's something that's indicating a potential threat in your environment, you need to know about it immediately, right? Then there's the medium value data where you want to have it, maybe it depends on your threat model, but it could be 2 weeks out, could be a month out, maybe a little bit longer, but you're correlating it and doing more near-term analysis to pinpoint maybe some threats that are a little bit like slower moving. And then finally, you've got your low value data that you need for compliance in your archives and maybe running your training models. So that's like a high level strategy. Let's like unpack this a little bit more and talk about specific pipeline features and functionality and how you can develop your tactics and processes. So the highest level is routing, right? So how do you enable those time frame scenarios that I just mentioned? You can just simply route the data into different infrastructure based on how you've kind of classified the value of it. So this is what allows you to kind of do things that maximize the efficiency of your system. You might also think about routing in terms of balancing loads. If there's spikes on your network's bandwidth at certain times, you can divert the traffic for better performance of your system. Could also be like regional data sets where you need to kind of bifurcate the data to do different compliance reporting. But again, routing is what can enable you to use different components of infrastructure to maximize efficiency while minimizing costs. The other capability in a pipeline is filtering. So filtering, the highest level kind of analogy here is you're trying to find that needle in a haystack. And if you have a massive, massive bale of hay, it's going to be harder to find that. Well, if you just simply collect less hay, you can find that needle more easily. So also you're going to be able to manage your costs. With a more narrow data set from filtering, you can run more targeted analyses. And then your detections and your parsing logic, all those types of things are going to perform more reliably and consistently if the data is more manageable. And then you can just have better speed. Once that data comes in, if it's a lower volume data set, it's gonna, your filters are gonna enable higher performance detection rules, and your search queries are gonna be faster. So it's gonna streamline your performance for your investigations. So you understand why to filter, but where do you filter? So you've got different options here that have various trade-offs. You can filter at the source, right? So a lot of systems and utilities are going to have settings where you can determine what telemetry data it emits. And configuring this potentially optimizes your network bandwidth. You're going to have lower demands and costs related to egress of data through the system. But you're going to have to do this one-off at each source. So it's not going to be very scalable. The next option is doing it in transit. So this could be some open source utilities like FluentD, FluentBit. Could be a native SIEM agent. Splunk has its universal heavy forwarder. Alien Vault has sensors that they deploy. And this allows you to centralize control to an extent and apply logic for filtering consistently, but there's still going to be an added cost, and you're going to have to deploy these in most cases per each source and do some configuration. And then finally, you can filter at the SIEM. So this is, if you think about like centralizing the administration, that has a lot of benefits for scalability. And you're also going to be apply more uniform filtering logic across multiple sources to make it, again, more scalable. And SIEMs, Panther, and a lot of other ones have really intuitive ways to include or exclude data with their filtering logic. This might result in higher upfront egress demands on your system, but the benefits tend to outweigh that cost. So we've covered why to filter, where to filter, what should you filter. So again, this is going to depend on your threat model, but you can think about a couple of things. So you might want to prioritize production environments because disruptions to production are going to be more, impactful and negative to your organization than in development and test. You might also just look at write and data events and not read events. This is going to vary again based on the threat model, but read events is just someone accessing the data. Write events means someone's like writing over and editing the data. And data events is kind of a subcategory. I believe CloudTrails defines this as things like downloads, transfers. Those are probably going to indicate that there's something going on that could be a data exfiltration attack. So you might want to prioritize the write and data events. And then just a couple other things here. You might want to just prioritize rejected network traffic instead of logging all of your usual expected traffic. And some specific examples of things you can just drop off: your web app traffic, your internet browsing, your workers like Googling or using ChatGPT, whatever it is. That's not going to be super high value. Neither is logs between trusted internal hosts and services. Those are already validated and trusted and verified. And then system diagnostics aren't going to have super high value either. So if you're looking for things to filter, here are some things that you can kind of start the process. All right, the other thing when we think about pipeline functionality, it's transformation. So it's, we talked about knowing the shape of your data. You're probably in some cases going to need to change the shape of it via transformations to make your analysis more efficient. So I'm going to give an overview of these, and then I'm going to hand it over to Panos to kind of show what this looks like in practice. So copy transformation functions allow you to take something that's buried in a nested hierarchy, elevate it to a first-class citizen, and make it easier for you to query or to analyze in your detection rules. Renaming, a lot of the default names in logs are really cryptic and obscure. So if you can rename them to something that's more easily understood across your team, it's going to be easier for you to build logic and optimize your processes. Concatenate is basically combining fields. So if there are multiple fields that you want to maybe combine into a unique identifier for the log, concatenation can help with that. The kind of flip side of concatenation is split. So really common way that split becomes important is a combined field like an address, where it's more valuable to have it granularly port an IP address. Split can enable those types of workflows. And the last two here are labeling and masking. Labeling is basically a way to define metadata on a key attributes. These are things you can do to assign a log coming production versus development versus test. There's some other ways you can do that, but the prod versus dev versus test is an important one. And then masking is ways you can kind of limit exposure to sensitive data. And this is important for some client compliance requirements. So enough of me talking. We're going to dive into a few scenarios. So Panos is going to walk through three sample scenarios that kind of build on each other. So I'll stop sharing and pass it off.
Thank you, Brian. Let me share my screen. And let's start by understanding my setup. My setup is actually very simple. I have a server. This is it. I am logged in. And I have a very simple web server running on it. And I have also set up FluentBit, which periodically, and more specifically, every 1 second, it runs a netstat command, which will collect all the open ports on my server. Then they are stored as a JSON on an AWS S3 bucket. Now, if I go back into my Panther, we can see that I have onboarded the AWS S3 source. And if I click on it, we can also see that I have defined a schema that is used to parse the data. And what is great about Panther schemas is actually that they are strongly tied. So for example, if you can see the first property here, it's a foreign address, the name, it's required, and it's typed as a string. So for example, if I receive an integer, I want this event to be dropped because most probably it's garbage since I'm expecting a string here. So this is a schema I have already defined, but I don't know if you noticed, if I go back to my log sources, I have an unhealthy one, and actually this is the S3 bucket I have onboarded. If I click on the errors and dig into it, I can see that the error is coming from trying to parse the internet string as an integer in this case. And let's find out why this is happening. If I jump back to my server and see the output of my command that FluentBit runs periodically in the background, apart from the rows that have the information that I need, right, the real valuable events, I have also 2 rows that, one of them serves as a description and the other one serves as the column names. So in this case, the classification error, it's coming because it's trying to parse the internet string as an integer, because the second and the third column of my events, I expect them to be integers. So it's a great case because my schema, caught errors, and these are events I don't want to run them through detections or to end up into my security data lake. So let's see how I can fix that. One option, like Brian mentioned, is to do it in transit. So for example, I could come to my FluentBit configuration and add a filter here. But in this case, I will get some free monitoring from Panther. So why not doing it here as well? Let's see how we can add the filter. If I visit the filters of my log source, we can see that I have 2 options. The first one, called raw event filters, you can think about it filtering logic being applied before parse time. So before Panther tries to parse the event, the filter kicks in. And then I can also use a normalized event filter, which you can think about it as post-parse time filtering logic. In this case, since it's after Panther parses the event, I can be smarter and actually reference properties of the schema and then select the operands and add the filtering logic that I want. So I'm getting classification errors because the incoming events, they're garbage and they can't be classified. That means that I need a raw event filter, right? So pre-parse time. Let's give it a name. I will call it netstat description to reflect the first row of my netstat output. And then the logic will be exclude the incoming raw event when it contains, and if I go back to my server, this one, this one. I will say filter when you find active, for example, in the event. Of course, I want to test my filter, right? I don't want to just deploy it and start filtering out data of high value, or the filtering logic not to take place. That's an option that Panther gives me, and I can actually fetch raw event data from my S3 bucket. So let's find one that I wanted to be filtered out. In this case, it's this one, right? You see? I will click on test event and my filter fails because I made a typo. And when I fix it, we can see that the filter now is applied correctly. Everything looks great and I can save the filter. And of course, I need one more in order to filter out the netstat column names. In this case, let's set the filter on proto. I'm sorry, contains proto. Let's fetch one more data to test my filter. This is it. Test event, my filter passes. Now I can save it. And now I can go back to my log source, resolve my classification errors. I might get a couple of more before the filter is being applied, but that's okay. I can resolve them later as well. Great. Now my log source is healthy, so let's move on a detection I have prepared. The detection is called unexpected port opened, and as you can imagine, it has a wide list of expected ports, right? These are ports I'm expecting on the server, for example, to always be on, right? And whenever I find anything else, any port that it's not in this whitelist, then I want to be alerted. Let's see how I can do that with Panther. As you can see, it's Python logic. The core logic is very simple. I'm fetching the open port of the event, and if the open port is not in the allowed open ports, I will return a true, which will trigger the alert. Otherwise, I return false. But if you notice here, the get open port function, it has some extra business logic, some parsing logic, which it's done in order to extract the port from the local address property, because netstat will send the local address, which is the IP address :: the port, and my detection is interested in the port specifically. So it's doing some carve out logic in order to extract the port. And last, as you can see, I have defined the title of the alert, and I want to make my alerts a bit more readable and to give some extra context about the detection that fired. So I also include the open port in my alert title. This is all great, but how about having the open port as part of my event, right? Instead of trying to apply again and again this get open port business logic. The good news is we can move this business logic earlier in the pipeline, and actually we can move it as soon as Panther parses the data in this case. So I will copy these lines and visit my netstat schema. And now I will go and edit it. So in the parser section, this time instead of JSON, I will select the script option. And now I get an editor that understands Starlark. Starlark is a dialect of Python. You can think about it as a subset of Python. And actually, it's more than enough. So I can do something like this, which is basically to paste my Python code I moved over from my detection. After parsing my event, at the end, I need to return the event. And the only change I need to make is to set the port in the event like this. And this will create a new property, like a new dimension in the event, which will contain the open port. Now, I have two options. I can either go below in my YAML and define the open port as a new property, as a string, for example, that it's always required, yada, yada, or I can turn on the field discovery. So what this means is that basically I'm lazy. I don't want to go and update my schema, and I will let Panther do all the heavy lifting. So Panther in the background will sample all the incoming events. So Panther will sample all the incoming events, do an on-the-fly schema inference, and then compare the inferred schema against my live schema. And any property that the inferred schema has and the main schema doesn't, it will be automatically added in my schema. So I updated my schema, which means that I can jump back to my detection and remove some good portion of the code. So let's start by removing the get open port. I see some messages on the chat. We can take them during the Q&A. So back to my detection, I removed the get open port function, which means I can remove this line as well. And now, instead of open port, I can say event.get open port, right? Because it's a first class citizen now. And I can go at the title as well and fetch the open port like this. Great, it's testing time. So if we scroll down, we can see that I have prepared two tests. One, it receives an event that contains an expected port. This is port 80, and this means that it will not trigger an alert. And the other one, it's about an event containing an unexpected port. In this case, it's a high value port, like 47,000. And in this case, I am expecting the detection to fire an alert. So let's update the test in order to contain the newly created open port. In this case, the port will be 80. Let me run the test. And it's passing. And now let me also update the unexpected one. Again, it will be the same open port property, but this time the value will be 47,000. Let me run the test. And this time the test is failing. Let's see why. Name get open port is not defined. If I go back to my detection, you can notice that in the title function, I forgot to remove this line as well. And this is why testing is great. So I remove this line. I will run my test again. Now it's passing, but I edited my detection, so it's a good practice to run all the tests again, just to make sure that everything passes. Everything is passing, and now I can save my detection. Look at how simpler my detection actually is now since I moved this business logic earlier. And this also will simplify my follow-up queries on my security data lake, right? Because now I have a strongly typed open port dimension that I can query instead of having to write extra SQL logic, for example, to do the port extraction. Now, let's assume that I have budget restrictions out of a sudden, and I need to reduce the ingestion volume I'm driving through Panther. Why not actually filtering out these ports earlier in my pipeline and having anything else run through my detections and then end up in my security lake? As you can imagine, we can do that by creating a normalized event filter. So in this case, I will add a normalized event filter. Let me name it, for example, port 80. And then I can reference netstat and say, exclude my event if the open port, if you notice it shows up as a well-known property, it knows the string, it knows the type, it's a string. And since it knows the type, it can also infer the operator. So in this case, I can say is 80. If I run test, it will fetch data from the security data lake. In this case, the new events with the open port haven't reached the data lake yet. it's fine. It will take 1 or 2 more minutes. I can save my filter. And actually, if I go back to my schema, the netstat1, you can also see the discovered property, right, from the field discovery. This is the one that we created with the script parser. And of course, I can go back to my detection and remove even more code. And I could do the same for the remaining ports and then just have a one-liner detection and say, I receive a port that, since I received it, I know it's not expected, then fire the alert. This is it. Back to you, Brian.
All right, good stuff. So yeah, that was a really good walkthrough of kind of the nitty-gritty of how all this stuff comes together in Panther. So we got a good question in the chat. We'll get to that in just a couple minutes. We just wanted to kind of wrap things up with the top reasons why your pipeline might be broken. So whether you've actually just started framing up a project or you're working on mitigating some issues in your environment, here's some reasons why things might start to run into some challenges. So you might not be ingesting enough data and limiting your visibility into the threats in your environment. There, it's just about prioritizing the logs by volume and feeling comfortable with bringing in the right data points, right? The flip side of that is you're ingesting too much data, and this is creating alert fatigue. You're adding to the whole needle in a haystack challenge, and it's running up costs in your environment. So again, filtering is your friend, whether you just drop the low value logs or you filter out the noisy components of your high value, high volume logs. Really liked how Panos emphasized testing. If you're not testing your pipeline functionality before it hits production, you're going to run into issues at some point where you're having limited visibility in your environment and you might not even know it until it's too late. So it's easy in a lot of cases to just stand up a test sandbox non-production instance and throw some sample logs in there to validate that the workflows and the pipeline feature functionality is working as expected. And the last two here, it's not really taking data refinement seriously. And what I mean by data refinement is all the transformations, and you can even explore enrichment capabilities to add even more contextual data to your logs. But when you're not aligning your threat models to the formats that your detection logic needs, it's going to result in noise and in low fidelity detection. So again, Panos mentioned it, and it's a theme throughout all of this, but embrace that shift left engineering mindset for your SecOps program and transform your logs earlier in the process. And then the last one here is just inefficient computing and storage. So if you're using the same infrastructure across everything, you're probably wasting compute resource on some things that are lower value or maybe moderate value that can use more efficient infrastructure. So again, think about it more modularly, divert your high versus volume, moderate versus low value logs. So we wanted to see what resonates with you all. So we're launching the last poll for our session today. Which of these reasons are the most resonant with you, the scenarios you're facing, and the pain points that you see in your environment? And if we didn't have one, use the chat and tell us, like, what are some things that you see it's a really big pain point? So let's see. See if the poll is running. All right. So yeah, it looks like, let's see. All right, now it's up now. So take a quick second to respond to that poll, and we'll flash up the results to see what people think. Okay, so we got a couple answers coming in. Give a few more seconds, but it seems like the top reasons are it's neck and neck between ingesting too much data and not testing enough. And not like running QA processes, which is definitely a common pain point. So I'll just quickly wrap up and emphasize some of the high-scale pipeline capabilities that Panther has. And we'll talk about a couple of customers we have. So GoFundMe, they are one of our customers, and they've emphasized that like Panther's pipeline capabilities have allowed them to onboard more sources and do a little bit more refinement with them to really add more value. And really, we have hundreds of out-of-the-box pre-built API-based integrations for common log sources, but where we see our customers really showcase the power of our pipeline capabilities is custom log support. So if we don't have a pre-built API integration, we allow you to easily onboard your custom logs. And we have capabilities that we didn't touch on, but they're related to what Panos showed, where you can just throw in samples of your logs and we'll automatically infer a schema based on that sample and then allow you to test it so that you know that it's working properly. And then, of course, Panos just showed a bunch of the capabilities in the pipeline filtering and transformations that we can do with your data in the platform. So with all of that data coming in, you're able to increase your visibility. So Zapier is another one of our customers. They were able to increase their visibility of logs by 3.5x, and they really emphasized the ease of use to do that. But that's just the front part of the issue. Then you need to be able to correlate all that data and take these atomic data points in your logs, convert them to signals, and then analyze sequences of activity, and then ultimately create those high-value alerts that are higher fidelity, not false positives, and that's going to make your team kind of operate at a high level. So last thing I'll touch on before we wrap up is we've just had our AI summaries that even streamline rapid response more so. And those are currently in private beta, where they're going to be opening out to, or sorry, they're in closed beta. They're going to be open to open beta very soon. And this gives you AI-driven suggestions and context on what's happening in an alert or detection, so that then you can streamline how you respond to that. So here's a quick kind of demo. Here's a correlation rule that we've built. It's then going to trigger an alert, and generative AI is going to give you a really thorough explanation of what's going on and how to respond. So the last thing I want to just emphasize here is like the key takeaway is that fidelity throughout your detections and alerts starts with your ingestion pipelines. So make sure that you're building high performance capabilities and taking that really seriously. And then your SecOps program will be off to a successful start. So I know we're already at time, and I again apologize for the late start today due to the technical difficulties, but we do have a couple of good questions. So let's see. I believe the question that came through, I'm trying to find it right now, but it was basically about how you use pipeline filtering and transformations to kind of like take in multiple EDR log data points, and then make it to where you can just run very few detections on those. So Panos, I don't know if you can speak to that approach generally, or maybe how Panther enables that.
Yeah, I can take this one. So you have two options. One is to go maybe the hard way and try to write transformations or like logic to normalize all the data into one, let's say, common schema, and that every DR schema will normalize into. Or you can use UDM. By UDM, I mean Unified Data Model. I think it's the most common approach to define one UDM and then map everything there. Or potentially even a combination of them, right? You have UDM properties and then some more exotic maybe properties that you can handle with transformations and data refinement, let's say, features.
Great. Yeah, a lot of different approaches there. And I think that was from Steve. If if you want to get a more hands-on demo of how this works in the Panther platform, we'll follow up and kind of walk you through that. So great. Another quick question here was about the correlation rules and AI summaries. So those are not generally available yet, but on June 12th, I believe, we're going to have those as part of our open beta. So if you're really interested in that, just reach out to us and we'll get you set up for that. The last question here, I think this could be a good one for Panos, is we talked about the reasons why your pipeline might fail. in the wild, like, are there any anecdotes or kind of like things that you see very frequently, Panos, that are important to keep in mind?
From what aspect? I mean,
Like, which,
the
like,
pipeline can fail for many reasons. Yeah.
yeah, like of these reasons why pipelines are broken, like, what do you see most commonly from
Oh, yeah,
customers?
yeah. Honestly, all of them. We've seen detections pushed in production that, they always trigger an alert. And of course, it's not ideal. Not ingesting enough or over ingesting and then trying to identify or refining actually your threat model in order to filter out more data in order to meet your budget goals. Like, honestly, all of them, all of the time. Like,
Okay.
they're very dominant. Yeah.
All the above. All right. Cool. Well, thank you all again for taking the time today. One thing I just wanted to call out, we're going to be at AWS Reinforce, which is Amazon's huge security conference. It's in Philadelphia this year. It is about a week and a half away, June 11th and 12th. So if you're there, come stop by booth 309. Check us out. We'd love to hear from you. And until then, thanks for joining and have a great rest of your day.